Hey everyone, in this video I'm going to show you how to make a 3-2-1 block using a design table. Let's do it. Alright, most important thing here is the strategy. How we're going to accomplish creating this 3-2-1 block that can become, say, up to a 4x4x4 block. Now one of the characteristics of the 3-2-1 block is that it's exactly 3 inches by 2 inches by 1 inch. So we're gonna make a strategy to do that. All right, first thing is that for a 3-2-1 block, we have to kind of pay attention to some things. Okay, this is 3 inches, this is 2 inches, the depth is 1 inch. We have 5 circles in this direction. We have 3 circles in this direction. What we have to do here is we have to figure out how to parameterize this thing. And I guess in the other direction, which I will just draw right here, we also have 5. And this right here is 1 inch. So we want to pay attention to the patterns in this thing, and then we want to extract out the relationship with the patterns. So when I have 3 inches on a length, then that results in me having 5 holes. When I have 2 inches on a length, that results in me having 3 holes. And when I have 1 inch on a length, that results in me having 1 hole. So the key now is to look at those numbers and to look at the patterns and to try to figure out what equation we might be able to discover that would give us that relationship. So 3 and 5, 2 and 3, 1 and 1. 2 times the number of holes minus 1 equals, 2 times the length, 2 times the length minus 1 equals the number of holes. 2 times 3 is 6, minus 1 is 5. 2 times 2 is 4, minus 1 is 3. 2 times 1 is 2, minus 1 is 1. So this is our parametric equation for knowing how many holes go in each side. The reason why I'm thinking about it that way is because I want to be able to specify whether this is a 1x1x1 brick or a 2x1x4 brick or a 4x4x4 brick. I want to specify the lengths for this 3-2-1 brick, and then I want to automatically put the holes in there. All right, so that's great. Another thing we can recognize while making this pattern is that when working with numbers, anytime we multiply by 2, we will end up with an even number. And anytime we have an even number minus 1, we'll get an odd number. And the reason why that's important is because it will help me right now to decide where I want to put the origin of this part. So it appears that I'm always going to have a circle in the very middle of these parts. No matter how big I make the 3-2-1 block, where the 3 and the 2 and the 1 are going to be integers, so it could be 4 and 4 and 4, and those are integer lengths. And so I'm going to place the origin right there in the center. All right, so my strategy then for this sort of thing, my strategy, that's messed up. Let's just get rid of that writing. My strategy for this then is going to be to construct a square with the origin right in the middle, and then extrude that out. It's kind of a bad picture. Let me switch this thing. I'm going to extrude that out. So by the way, here's our planes. I'm going to put that right in the middle. Set of planes right in the middle. So I'm going to extrude out from both sides in order to get that to work right in the middle. And I need to think now a little bit about my default part. In order for me to be able to ultimately have a 4x4x4, it will help me when I'm making this to get all those features into the first version of this part that I create. So what I would like to do is create not a 3-2-1 block, but maybe a 4-3-2 block. That will be my default, will be a 4x3x2. Then I can have patterns going in every direction, and that will be good for me. So I will start with the 4 inches and the 3 inches, and then I will extrude it backwards 2 inches. Then I will go ahead and pop in to my part a center circle, and I will do that center circle and then put a chamfer on that circle. Chamfer. And the size of that circle for these 3-2-1 blocks is going to be 0.035 inches. All right. And then I'm going to put a chamfer on there, a small chamfer, 40 thousandths. All right. And then I'm going to pattern both the hole and the chamfer in this direction and this direction, and then in this direction and this direction. Each case, I'm going to have the pitch of 0.55 inches from center to center of those holes. And I'm going to do that on my first face, and then I'm going to do it on the second face, and then I'm going to do it on the third face. So I'll do this for all faces. Then I'm going to put a chamfer around all the edges of the outside block. And I will put a 20 thousandths chamfer on that. And then I'll open up the design table and start to mess around with what's going on in there. So that's my strategy. I'm going to go for that and see what happens. Workflow, save it, get into my units, get a material applied. Okay, good to go. I'm going to start this on the front plane. Okay, that's great. I made a little a little thing that's kind of messed up in the way that it looks. I'm going to use the geometric relations to get this right where I want it to go. Just here, make that coincident. Find the other center of this thing, make it coincident. Great, now we're going to dimension this. And I had decided I would go 4 inches on this, and I would go 3 inches on this, and I would extrude it out 2 inches, which I'll do right now, 2 inches. And now I can see that I do not have my plane, my front plane in the center of this. So instead of extruding blind, I'm going to extrude from mid-plane, and that will pop it right in the middle. Okay, so now I have my part exactly as I had wanted it to be. Now on this front plane, I'm going to pop a hole in here. And that hole is going to be right in the center of this. Wow, that's giant. That's okay. I'm going to dimension this at 0.035, which is 35 thousandths. Is that what I wanted? That's not what I wanted. I'm off by an order of magnitude, 0.35. Okay. I need to actually just check to see if that's right. So I'm grabbing the 3-2-1 block. I'm grabbing my digital calipers. Oh, yeah. I was off by an order of magnitude. So that's right. It's 350 thousandths, not 35 thousandths, as I had mentioned before. Okay, so that's that. Now I'm going to take that sketch and I'm going to do an extruded cut, and I'm going to not go one direction. I'm going to go both directions. And I'm going to go both directions through everything. That way when I change the size of this, it will still be just right. Okay, so now time to add a little chamfer. And we're going to add a chamfer to this. And we better flip this around and add a chamfer to this. So we have a chamfer on both sides. And I said we wanted to do 40 thousandths. Okay, so that's looking good. Save that. Excellent. Okay, now it's time for us to create some patterns. And I want to take the extrude and the chamfer. So I've highlighted them both there. And now I'm going to go to linear pattern, create a linear pattern of both of those. The features you can see down there are chosen. Direction. Okay, direction 1. I am going to go into this direction first. That's my X direction I'm seeing down here in the origin kind of marker. I'm going to go my X direction first so I can keep track of this. My X direction, 0.55 on the pitch. And I want to have, okay, this is 4. So I have 4, inches on that. So 4 times 2 is 8 minus 1 is 7. So I should have 7 holes in here. So I need to add one more to this. There we go. And then in my second direction, I'm going to pick the same direction that I picked before, except I'm going to flip it around. And I'm going to switch my pitch to 0.55. And I'm going to tell it to pattern the seed only. Huh. Is that what I wanted? Oh, yes, that is what I want. But I need to switch it now from 3 to 4 so that in total I have 7 holes. Okay, so that's great. And that's looking good. Now I want to take this pattern and I want to make a linear pattern of this pattern. And I'm going to go in this Y direction. I can see by the origin thing down there. Okay, direction is this one. And we're going to have the same pitch that we just had a second ago, but we're going to drop one of those. And then in our second direction, we're going to go in that same direction that we did before, except we want to pattern the seed only and not the entire thing. And we're going to flip that around. And we're going to drop it by 1. And this now has given us that proper pattern. So that's looking good. Okay, and do we have chamfer on the other side? Yes, we have chamfers on the other side. Great, so I did that on one face. I now just need to do it on the remaining 2 faces, which I'll blast through doing just right now. Okay, so I've now created the entire set of patterns on all the faces. So that's looking good. Let's save this thing so we don't lose that. Then we are going to go and put a tiny chamfer around all the edges. So we're going to grab those. This chamfer is going to become basically half the size of the one we're seeing right now. But this is good actually to help us see everything. Okay, just grabbing all of those pieces. I didn't want that one. We just delete it. Don't do clear selection. You'll lose everything that you did. Okay, great. That's what we want. We want to switch this down from 40 thousandths to 20 thousandths. It's all as one feature. Okay, great. So that's that. We now have our 432 block, and we want to save this. Save. We're in inch-pounds seconds, so that's great. Now what we want to do is come in here and make our design table. And so we are going to insert, not tools, I'm in the wrong thing, insert, tables, design table. Auto blah blah blah. Let's uncheck this enable cell drop down list. Everything else is looking pretty good there. Okay, so we'll have a reasonable set of parameters that we need to bring in. Okay, bringing all those in now. Great. So now the key is to determine how we're going to do this. And the way that we're going to do it is that I'm going to add in some columns to the left of A. And to the left of A, what we will be figuring out here is some kind of user inputs. And to make this extra clear, what I like to do is take this first one here and fill it red. I want to fill it red so I know that everything to the left of this I can change. Oops, I changed that the wrong way than I wanted it to. And for my 3, 2, 1 block, what I am going to do is I'm going to have my length. Okay, did that type? No, that didn't type. My length, my width, and my height. Okay, and for our default, our length and our width and our height were 4, 3, 2. All right, so now I can see in my default, I have this 4, 3, 2. And this is good. I actually kind of want to leave my default just the way it is, and I want to not mess it up. And so what I'm going to do is copy this entire cell, copy, and I'm going to paste it into the next row. So I'm going to copy the whole row and paste it into the next row. And this one's going to be my 4, 3. I'm changing the name of this one to 4-3-2. And what I'm going to do here is I'm going to see that I can get all the calculations to work out just right. So now I can see in my design table D1 at sketch 1 is 4, and D2 at sketch 1 is 3, and D1 at Boss Extrude is 2. These are my 4, 3, and 2 from the definition of its size. So what I'm going to do is I'm going to step into this cell. I'm going to hit the equals sign, and then I'm going to click over here on length and say that that is now equal to the whatever is in this cell. And I'm going to do the same thing to the next one. That's going to be equal to whatever is in this cell. And then this one is going to become whatever is equal in this cell. All right, so that's great because when I change this to a 3 to make it a 3, 3, 2, my design table parameter here it changes. For now, I'm going to leave it the same as the default so I can get the same numbers as the default. If we go to the next one, this is the size of the hole. This is the size of the chamfer on the hole. This is the other dimension for the chamfer. This is the pitch. This is the, what is this one? Okay, this is the number of holes that we have in one direction. Okay, so we did our pattern from the center, so we have to think for just a second about how this is going to work. It turns out, I guess, that the way that this is going to work right now is that I better do this in a way that is probably most mathematically correct, okay? So this one is going to be holes, all right? And because we did our pattern from the center out, we can see over here that we're going to end up with the same exact number of holes as we have lengths on everything. But I do like to think of the holes as the length times 2 minus 1. Okay, the length times 2 minus 1. So the way that we would really be doing that in this equation, I know this is a little bit ridiculous, but I'm just going to do it anyway right now. Quantity length times 2 minus 1. Length times 2 minus 1. That's right. But because we're only doing half the pattern at a time, really what's happening is we are doing, we want to, in essence, just reverse everything that we just did. And this is why I'm saying that it's ridiculous. I know. So we are going to take this quantity. I know this is really goofy that I'm doing it this way, but at least it preserves the parametric model that I had in my head. And I've messed that up somehow because I ended up with 16. So what I've tried to do is just undo this. So this times 2 minus 1. Okay, let's just actually just jump out of that for a second. This is the number of holes it will be in total. And so let's just add one more to this. Insert. Okay, this is the number of holes that I have in the length direction. And this is going to be the number of holes I have in the width direction. Width direction. And one more. We will add to this. Okay, and then this is the length of the number of holes I will have in the height direction. Okay, I'm getting a little bit crazy with this. And then because of the way we did the pattern from the center, which I actually think is a little bit easier than doing the for the 3-2-1 block than doing it from the edge. Now for the Lego brick, that's a little bit different because you're not always going to have a stud right in the middle, but we are always going to have a hole right in the middle of the 3-2-1 brick. So I'm going to insert 3 things here. And this is where I was saying before it's a little ridiculous because what we're going to do is, so this is going to be our hole pattern in the L direction. And our hole pattern in the L direction is going to be equal to this plus 1 quantity divided by 2, which is a complete, just absolutely undoing of what we did in the original equation. But like I said, it allows me to preserve in my mind the parametric model. Okay, so this is the hole pattern in the W direction, and this is the hole pattern in the height direction. Okay, so now let's just shrink some of these cells so we don't have to look at them. If I just double click right up here, it kind of shrinks them to the size that they need to be. This just allows me to get this all on the same screen at the same time. Okay, now I can open up this just a little bit and maybe a little bit more. Maybe we can see the whole table. I don't know if we'll be able to. Yes, perfect. Okay, so this was the length, this was the width, this was the height. Then we get over here to pattern number 1. This is the pattern in the length direction. And this is also the pattern in the length direction, but the opposite way. This is the pattern in the W direction. And this is the pattern in the other W direction. And then this is the same thing, the pattern in the L direction. And this is the pattern in the other L direction. And this one is the pattern in the height direction. And this is the other pattern in the height direction. Okay, and then what is this one? Okay, yeah, this is the other face we got to do. So this is the pattern in the W direction. This is also the pattern in the W direction. And this is the pattern in the H direction. And since we did that from the center plane, there's 2 patterns that we have to do, and that's the other one. Okay, great. So the reason why we did that is because it allowed everything to be controlled by these inputs that are right here. Okay, let's make this a green color. Okay, these inputs are going to cause all of the design table, everything to the right, to automatically change. So I change this, for example, to 3. I'm going to see all of the stuff in the design table change. Perfect. That's actually exactly what we wanted. So we're going to leave that like that. And we're going to take this thing, copy. We're going to paste it down here. Paste. And we're going to paste it again. Paste. And we're going to paste it one more time. Paste. And we're going to test a few things. Okay, right here, I'm going to go do a 3-2-1 block, like a traditional 3-2-1 block. Then I'm going to come down here. So I better switch this to 3 and 2 and 1. Okay, I think that will work. We'll find out in just a second. I'm going to switch this one to a 2 by 2 by 2 block. It's good to also test, as I'll show you in just a second, the extremes. And the extreme that we want to test here is the 1 by 1 by 1. And actually, we should probably test the 4 by 4 by 4 as well, which means I will make one more row. Okay, let's copy this. Copy and make one more row, paste. And we're going to make this one a 4 by 4 by 4. 4-4-4. And I think we are ready now to see what kind of errors we get. So we're going to click out of this. It's going to tell me some new configurations have appeared. There they are. Thank you very much. Didn't have any errors yet. That's great. Come into my design table, and I'm going to check the 3-2-1 block. Okay, now this is it. What are we doing here? This needs to be rebuilt to reflect the changes. Okay, good. No copy is specified for this pattern. Pattern 7 and 5. Okay. So there's my 3-2-1 block. I'm going to go back over to my default for a second. I'm going to come back into my 3-2-1 block. And Solidworks has fixed its problem, whatever its problem was. I'm not entirely sure. We're going to see this in some of the other ones, though, so let's try that. So we come into our 4 by 4 by 4. And that is correct. Okay, so I think it's worth just saying kind of what might have happened with that error. Solidworks was trying to resolve a few things in the order that it was rebuilding, and it had an error. I just kind of looked at it and then said I wanted to continue, and we worked through it. Okay, look, okay, now this is an interesting one. When it's a 1 by 1 by 1, there is no pattern, but I think you can have a pattern of 1. So let's try the rebuild. Let's continue. And there's my 1 by 1 by 1. And let's go to our 2 by 2 by 2. And go back to our 1 by 1 by 1. And we have now created this design table that can do all of these. Great. Excellent. Perfect. So that worked out really well. That's how we create 3-2-1 blocks, or the 4 by 4 by 4 blocks, or the 1 by 1 by 1 blocks using a design table in SolidWorks. Thank you for joining along. I'll see you in the next video.